So discrete event system simulation is the modeling of systems in which the state variables change only at a discrete set of points in time. As we have said, that is the definition of discreteness, and the simulation models that we create in such sense are called discrete event system simulation models. Now, the simulation models are analyzed by numerical rather than analytical methods. Now, in analytical methods, we employ a deductive reasoning of mathematics to solve a model. For example, for a linear programming model, you use the simplex algorithm or the interior point methods to solve that model analytically. Or if you have differential equations which are solvable, then again you are solving that model. But there are some differential equation models, and just like that, the simulation models require numerical methods to solve the problem. So we need to employ computational procedures or algorithms to solve a model here. There is not an exact solution method for the simulation models. We employ numerical methods. And what we say about the solution of the problem in simulation, if we create a model, we do not solve it, we run it. So if you have a linear programming model, you solve it with simplex algorithm. But if you have a simulation model, you run it with a simulation software. So the models are called to be run. We run simulation models, and the results of the simulation models are analyzed. So running a simulation model means what? You are basically observing it for an amount of time, just like you are intending to observe the original system. But trying to observe the original system, it is going to take some time. So we create a simulation model and we run that model to observe it. Now, when you run a dynamic simulation model, an artificial history of the system is generated from the model assumptions. So the model itself is going to create an artificial history. So this is the point where you need to understand the concept of artificial history. So if you run a model in a software environment, it is just going to produce some results, some performance metrics. For example, you can observe a supermarket for 8 hours, but it is just going to be very fast in computer environment. Maybe it is just going to end in 8 seconds. All of the events that have happened, all of the durations can be recorded, all of the state variables can be plotted with descriptive statistical methods. So this is just going to be the artificial history that you have created with the simulation model when you run it. Now, after collecting this artificial history, the observations collected are going to be analyzed statistically, and we are going to estimate the performance measures of the true system. So the model is going to produce an artificial history. This artificial history, when statistically analyzed, will help us to estimate the actual performance metrics that is supposed to happen in the original system. So these estimations are only reliable if the model can represent the original system valid enough, and it is not too complex. So the model should be a valid model enough to accurately estimate the true performance measures, which you will not be able to know in any way, because it is impossible for you to practice an experiment over the real system. So you wouldn't know the actual performance measures if you intend to make an experiment, okay, or make a change in the system. It is impossible. So what you can do is to create a valid model of that system and run a simulation on that model, and then you can estimate the performance metrics after generating an artificial history.